Yeah, so let me introduce myself. So my name is Laurent Troger. I am a system engineer as a background, started in the defense. I then moved into the rail industry. I had 30 years in rail, but also I also worked in the aerospace industry for 15 years. So I have climbed two corporate ladders. So my last position, I was the CEO of a large organization, Bombardier. And 6 years ago, I left the corporate world and I moved into another world, which was in fact more in the investment and advising. I am passionate about energy and quality. And Gert told me about APQP. We had the opportunity to meet in a previous life. And I said, yes, I'm ready to come. I did not know that it was here so far. I thought it was in Copenhagen, but this morning, nevertheless, I took the car very early to be with you. I'm going to be very provocative with you today, because I think it's a good moment for us to exchange and to speak about what it is about. So when we are talking about quality, when I was a CEO, I can tell you that it was a very interesting conversation because quality was never on the agenda. So you imagine I was running a 10 billion organization, and how many times we were discussing about quality? Never. So when was the moment where we were starting to talk about quality? When was the moment, or the only moment, when we failed? And then we arrive into a big conversation, which is why did we fail? But of course, it was far too late, because then, of course, the famous cost of non-quality became exponential. So we had a lot of conversation about cost of non-quality, but not about quality. So I'm coming from two industries that have a lot of good examples I'm going to share. Of course, they don't exist in the wind energy. They don't. They cost a fortune. Now, the point is, can we afford to make such mistake? Can we repeat the mistake? So as an optimistic guy, I will say, I can accept we make a mistake. I would not accept to repeat the mistake. Now, in the world of today, is it possible to make a mistake? That's a real good question. And I'm not sure that sometimes we can afford to make a mistake. I'm not sure of this. Now, as far as wind is concerned, I'm going to be provocative because I'm going sometime to go back to the mistakes that have been made. We're going to share whether or not we have the same root causes. And we're going to discuss, are you making the mistake again, or are you correcting the mistakes? And are you preventing these mistakes to happen again? Now, why is it an important conversation? It's an important conversation because at the beginning, it all starts by an economic equation. And the economic equation is very simple. We need to generate more revenue over the asset lifetimes. So if you take 25-year asset lifetime, we need to generate more revenue than what it will cost. And you can be a public organization or a private organization, it does not matter. You need to make sure that you are going to cover all your costs with the revenue. And then the critical conversation becomes very challenging when we all in the room, we make a promise. And this promise is in new environment is called FID. This famous moment where we are all making a promise about what it will cost and how much revenue we'll get. And everybody's saying, oh, it's going to be positive. And you are saying, oh, yes, it's very positive. So we are all fine. Now, the point is, at that moment of promise, to what extent we are very clear on the risk we take and how we are going to mitigate those risks to make sure that the economic equation will remain with a positive answer. And in other mature industry, we can see that this economic equation sometimes is not on the right side. But now on the wind energy, it happens a lot as well. So it means that you, when we are going to talk, you have to make sure that you remain on the positive side of the economic equation. And if you are not, what is it you are going to change to make it a positive answer? So when I look back to what has happened over the last year, what is very clear is that this industry is facing dramatic challenges. And we can see that some projects are canceled, but we can see also that some projects are being impaired. So, and it's an interesting conversation when you are in a CEO boardroom with the board and you come and say, we have a simple conversation, which is impairment. And so what does it mean, an impairment? It means that you are just writing off, in fact, the negative part of the equation to make your equation positive again. But the problem is that someone has to pay for it. And someone being an investor or someone being taxpayers. But the problem of the impairment is a critical one. And what I can read about this industry is that it is happening. Now, what does it mean? It means that the economic equation is very challenging. So I would address today with you 6 simple questions. And I'm not saying that I have the answer, because it would be very arrogant to say that I have the answer. I'm provoking a discussion, and I'm bringing you some example of other industry, what they've done, and maybe where you could look at. So I don't come with an answer. I come with, okay, those are the questions. This is what has happened in other industry. Maybe you should have a look. Of course, when I say that with a very strong motivation for you to start to really understand that you have the opportunity to make a big impact. Because let's not forget that the promise is not only an economic equation, but it's also an ecological equation. So the 6th question is about, where is quality assurance failing? What does APQP4Wind look like? What must change in short term? What are the scope and boundaries, and what is this presentation about? So I'm going to go through this with you this morning. So what is the approach that and the methodology that I'm using is, of course, a very simple one, very well known by you. It's a gate-based quality framework, but across the full life cycle. So it's a full life cycle. So we start from the requirements to the decommissioning. So it's a full life cycle. And it is paired with a 3-dimensional capability maturity assessment. So here, this is the big word, the capability maturity assessment. What I observed when I was a CEO, when I started to put in place the quality gate, to what extent the people in the room are capable enough to manage the gate. And that's not an easy conversation. Whatever gate you have an answer at the end of the gate, but what is it, the capability you have to make sure that you have the right quality gate review? And nobody has asked, but do we have the capability? And do we make sure that we have the right people in the room to talk about it? And this is an interesting element because we have never done the assessment. When we started to do the assessment, we realized that we had some gap in this area. So you are familiar with this 5 strategic phase of any project. So requirements and design, procurement and manufacturing, transport, installation, commissioning, operation and maintenance, recapitalization and decommissioning. So 5 strategic phases, 9 quality gates. You could have 10 or 12, depending on how you want to organize yourself, but you are all familiar with this. So now when we arrive to the capability assessment, and we have a 3-dimensional, it was about the skills, the processes, and the tools in order to assess to what extent we have the capability to do the gate. And what we realized is that retrospectively, we were not at a minimum level of capability requirement to manage the gate. And what we discovered is that in some area, we thought that we were good, but we were not very, very, very strong. Now, when we started the capability assessment, of course, it all starts by the tools. Do we have the tool? And then it goes to, okay, but we don't have the right tool, so let's go for a new tool. And then we are going to improve our capability. But most of the time, we forgot that it was also about the skills of the people. And then maybe to discuss about the process. And when we go into the capability maturity assessment, we understood that we have to upgrade the capability at the same time that we were, in fact, leading the gate. And I'm going to go with you in some critical gate where I consider, coming from two other industries, the maturity is insufficient to make sure that we have a predictable economic equation delivery. And this looks like a very simple conversation, but if you ask yourself, who is coming at the gate? How much are we capable to manage these gates, and how we are going to conclude these gates to make sure that we are dealing with the risk? That's a very, very important conversation. Most of the time, this conversation does not occur. Nobody discusses about the capability of the people around the table at the gate. So I have gone through in two other industries these questions, and I have six findings, and each of them is a structural capability gap. And what we can say is that those gaps, they produce a visible economic challenge. So when I'm going to talk to you about those gaps, I'm going to give you an example about what was the result of this. And you can see that sometimes it's really big. So because when you are moving to very high position in an organization, you can see that the problems are getting bigger and bigger. So 6 structural capability gap. So I'm going to go through requirements management, system design and FMEA, subsystem contracting, product delivery and process quality, system testing, commissioning, operation and maintenance. All those are very well known from you in your own industry. I'm going to give you 6 examples, and of course they don't exist in your industry, of course. Now, if they do exist, it's really a surprise. So the first one is about requirements management. I can tell you that this is one of the toughest issues we have in all large-scale operation capital-intensive project. The level of maturity in requirements management in rail industry and even in aerospace industry is not at the level where we can say that we can predict the end result. And I can tell you that the aerospace industry and the rail industry are much more mature than your industry, much more mature. And why? Because, of course, they have a long experience on this. Nevertheless, it happens that the management of requirements is a new discipline that has come recently, and we are still at the beginning of this discipline. And so today, what we have, when I go to the capability maturity assessment of requirements management, we have some good engineers pouring down requirements into a beautiful database that is too big now for us to manage. Even an Excel sheet is too complex, so we go to new tools. But then it remains a database, and then nobody cares. And then we hope that's going to work. Now, if you take the Berlin airport, the Berlin airport is a catastrophic project. If you discuss with a German guy, who is German in the room? Okay, Kim, I'm not going to ask you to stand up. But it's what I call the shame. And I don't know if you have seen this airport, but this airport is really a beautiful airport. It's a very, very efficient airport. But during 7 years, it was not in operation because there was a gap in requirement between 3 systems, and nobody was in charge of the complete system itself. And for a safety critical functions, nobody wanted to sign. And then what they discover is that the requirements have not been managed very carefully at the beginning, cascaded down to the 3 systems in a coherent and consistent manner, so that at the end of the day, they did not get the expected output, and nobody could sign. And in Germany, when you sign, you are personally liable for the signature. So it means that if you sign and there is then casualty, you go in jail. So nobody wanted to sign. 7 years. So people would say it's a farce. Now, when you go to the root cause, it failed at the requirements management. And I don't want to blame the German there, because I can tell you that they have done a lot of work in requirements management. And some of German companies in this industry, I know, are investing in this area. And it looks like a simple matter. This is perhaps one of the biggest matter. So now, when you go into this capability maturity assessment and requirements management, in most of organizations, you are between 2 and 3. So if you take the scale, which is the CMMI-based scale, I don't know if you're familiar with the 1 to 5, okay? 1, it's a bit archaic, and 5 is the dream. 3, it means that you are consistent, predictable. 2, it means that you have something in hands, but maybe that you have some bad surprises and good surprises. I would say that the industry is between 2 and 3. Now, 2 and 3 means you are not predictable. So it means that what you are doing today is not enough. So either you do something completely different to reach minimum 3, or you will still have some major surprises. Now, is it acceptable? No. But on top of that, you have to deal with it very fast, because the requirements in your industry, like in any other industry, your requirements are volatile. And we will come back on this later. Your requirements are changing. They are changing over the lifetime of the asset. So the discipline of end-to-end requirements management is critical. And you cannot say, oh, I've done it, it's in the database here. No, it becomes a living process all along the asset lifetime, and you have to deal with requirements changes as well. And I will give you an example after. The second example is, of course, system design. So I come from an industry where system engineering was not very developed. So in wind energy, system engineering is very developed. You have a lot of capability. The only issue is that when you go to system design gate, system design quality gate, and you go to failure mode and effect analysis at system level, back to requirements, you discover that sometimes this gate has not been very, very well managed. And this case that you know very well is the famous 737 MAX with the new engine that was in fact implemented, but they completely failed, Boeing, they completely failed in this area to make sure that all failure modes were very well identified and managed, so that at the end of the day, we were not trapped into a situation where the pilot has no clue about what was happening on the aircraft and he was doing the wrong thing. 2 fatal accidents. 2 fatal accidents. And some of you might have seen the public hearings on this, but this was really, really, really bad. So when you go there, you have the same conversation about to what extent the system design quality gate has been prepared and reviewed, and everybody signed off, and it was like a miss. The third example is less known, but this is the way how a system integrator, here it's a public organization, is MTA, so this is the New York City, is the system integrator of a big urban network, and they decided to cascade to their subcontractor a new train control. And here they failed in the way they were managing their subcontractors. And here it's a big failure I've seen in many industries, is that the relationship between the system integrator and the system the system supplier is such that it's a one-way conversation. So I give you a contract, that's my requirements, you have to deliver. And what we discover is that, in fact, it's not a joint understanding of the requirement into a joint risk register, into a joint program. And most of the time you go one way, and because you consider that you are the integrator, you know everything, and then you give you award the contract to a system supplier, but the system supplier is not necessarily able to deal with your contract. And then what they are failing here is to make sure that they have all understood the same thing about the system itself. And here there was a significant gap. This one is very famous. I don't know if you are familiar with this Qatar and Airbus issue. So I gave you Boeing at the beginning, just before, and then Airbus. I try to balance that. So who is familiar with this painting issue on the Qatar airplane? Only one. That's not a lot for quality people. So why is it so I present this case? Because it's all about process versus product. And then you know that, and in particular in APQP, you have a very big conversation about process quality versus product quality. And here you had a significant process quality issue with Airbus, not the product itself. The process quality led to this situation where the painting was not very, very good, but it has also an impact on the safety of the plane. So it was a big argument, big fight, 2 billion dispute in London, and then there was a kind of agreement. Why I insist on process? Because it's not about what you do, but how you do in order to achieve the requirements. And if you believe that it is only enough to look at the product at the end, I think that it's too late. So you have also to review how you do things, which is mainly on the process itself, to make sure that you have the right quality of your processes to ensure that the product will be delivered as per your requirement. And this was a big issue. So now you would say that Airbus, come on, you know how to paint plane. So why did they fail? Why did they fail the painting? Because they changed the process. And when they changed the process, they made a mistake. And they say, oh, very, very interesting. So we have produced this quantity of plane without problem, but suddenly we failed to change the process. And we have, in fact, by changing the process, brought a mistake, which has changed completely the product quality. So the next one is about testing. So this example is in North America. There is a new high-speed trains in Northeast Corridor with Acela and Alstom. And Alstom delivered their trains very late, 3-year delay. The major issue was the fact that they did not have a very clear understanding of the infrastructure requirement. In new industry, it's about interfaces. And the interfaces were not very clear enough. And they failed, so they had a lot of tests to do. The test led to redesign, retest, and then the long loop, and it took a lot of time. Where they failed was in the modeling of their environment and then doing the right simulation to make sure that they had the right design. And then the last one is a train control, which is being developed in Europe, very famous in Denmark. I don't know if you heard about that, ETCS, where in Denmark it started in, I think in 2012. I think you are 10-year delay in Denmark. And in fact, big failure, because in fact, the system itself and the requirements are not converging into a reliable system that enable the operator to operate smoothly, contrary to the promise that was done. So those 6 examples give you quite, I think, a very provocative statement about how much other industry, rail and aerospace, are in fact struggling. So what are the implications of this? So the implication, the quality gates at each gate propagates through the project, a risk register into the financial model, and end as written down asset and a refinancing events. This is what we are here today. The consequence of this is significant impact. Now, those impacts, when they materialize, they can affect also decision makers and the way they decide. And here we have to be very, very careful, because then after there is a kind of dominant thought that says, as an example, wind energy, there is no return. It's too expensive. It's not efficient. Why, in fact? Because the economic equation is not positive. They are still making promise, but they don't deliver as per the promise. So we need to find an alternative. And you have some decision makers and some politicians that are convinced that wind, as an example, is not the right energy. It may be tomorrow if you have a better solution, but it's not today. So we have to be careful when we go into this type of conversation. You have also the impact on decision makers and how they receive it. So from quality gap to write-off in 9 steps. So I will go quite fast on this. So I come up with 6 recommendations. The first one is on requirements and risk management at every gate. So, and here this is very simple. Make sure that you have your requirements well established. At the same time you do your requirements, you start your risk management. And they go in pair, requirements and risk. And this is where the requirements support the promise, which is your economic equation. And your risk management is, in fact, the critical management judgment you have on the assumptions that have been made and how much you validate your assumptions all throughout the project lifecycle. Now, when you do that at every gate, it means at every gate you go back to your requirements and you make sure that you are not in what I call an open bar situation, which means that we are always closing the loop. And when you close the loop, then you know. And when you know, you become predictable. Now, when I go into project, not in wind, and I arrive at the end of the project, and I look at the critical requirements that are supporting my economic equation, and I am close to start the operation, and I discover that I have major requirements that have not been validated. What do you think is the situation for a decision maker? Very, very challenging situation. So recently, I give this example to you. Recently, London invested on a major project, the Elizabeth line. It's a commuter line. It's one of the busiest lines today in London. It moves more than 500,000 people per day, and they want to go to 700,000. The promise at the beginning was 30 trains per hour, 30 trains per hour. The system today can deliver 24. They are missing 6 trains per hour, almost 30%. Now, if they want to grow from 500,000 to 1 million per day, which is the target, they will need to dramatically improve the line capacity. But everybody says the project is finished. It's finished. I know if you want to reopen the design, okay, but that's another project. Then we are starting to discuss about recapitalizing the project in order to deliver the right performance. So it's a no-shit moment. I call it the oh-shit moment. When it happens, it's very, very difficult. The second one is system design tested across all modes. And here what is interesting, when I say all mode, is that you need to put in place a system engineering authority, and you need to test all mode of operation. And you need to make sure that when you do that, you are consistent all across your operation. What I said to a system engineer is that 10% is nominal mode, 90% is degraded mode. So when you have done a system design for nominal mode, you've done 10% of the job. When you are now going into the degraded mode, that's becoming another conversation. What is the most challenging conversation right now on complex system? Resilience. Have you heard about resilience in system design? Who has ever seen a spec about resilience? You know, you go to your requirements. How do you define resilience? It's not very, very easy to see this. So for instance, if you take an urban network, you take the train at peak hours in the morning, 7 o'clock, you arrive at the train, you want the train is delayed by 2 minutes. I say, shit, 2-minute delay. Now, what you don't know is that the 2-minute delay at the center of a city is a 1-hour delay at the end of your network. So it means the people that are commuting will be 1 hour late. Then I say, the system is not resilient. It's not acceptable. So in the 90s, when we developed system for aerospace and for rail, we completely forgot the resilient requirement. Now it's coming up more and more. When you take the plane, and you take at this system, you know the plane, and then you have, for instance, a big storm, and then it generates delay and delay and delay, and sometimes they cannot converge again. And then you say, but what is the resilience you have? How much time you need to recover normal operation after a single disturbance? Is it a requirement? Not sure. So if it is not a requirement, then you can say that you are living at the expense of your system design. You simply don't know. So some systems are well designed and they will recover fast and others are not. When I said, maybe you should put that into your system design quality gate and to make sure that you revisit for all mode of operation, you revisit your requirements and make sure that your requirements are very well identified. And resilience is one of them. In wind energy, that's exactly the same. The third one is joint contractor agreement. Today, what I've seen in many industries, it's top-down, one way. There is no collaboration between system integrator and system supplier. Or when there is, it's a farce. Because it's not a farce when you start to comment, where is the risk and who is going to take the risk? So one day I was with one of my biggest contractors and I said, okay, let's do this exercise. I'm going to assess the risk and you are going to assess, I'm going to assess your risk and you are going to assess my risk. We brought the two teams together. Guess what? We did not have the same risk register. So they were very good at pointing out where we were weak, and we were very good at pointing to them where they were weak. Now, we said, but do we work jointly together to make sure that we are addressing both? No, because the first things that the contractor will do, first thing, they will protect their financial position and their legal position. So they are not interested by the contract. They are interested by first protecting their contract so that they are not facing tomorrow liabilities. So the behavior is not a behavior of open mindset. We work together, we are going to share. No, it is, I'm not going to take more risk, and I'm going to make sure that if you want to demonstrate that I am a problem, you will have to work hard, because the first things I'm going to do is to protect myself so that you cannot demonstrate that I'm wrong. So you arrive into sub-optimization between the different players in the value chain. And in particular in Europe, this is very, 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 very true. In China, this does not exist. The speed of trust in China is much faster than here, much faster, because in fact, they are jointly working together. Where in Europe, we tend to be, in fact, over the fence, contract in between, and we think we are aligned, and we are not. So I can give you many examples, not in this industry, but in other industry where it fails, just because in fact there is no collaboration between contractor and the contractor and the contracting entity. The first one is the process QA in contract. So I showed you the painting. So I will not repeat the painting, so because in fact it's very visible, it's hardware. So I said, guys, it's very easy, this one. Now, what about software? How much are you looking at process quality in software? And then I said, very, very interesting. So you go and contract, and most of the systems now include software. And I said, how do you see the process quality in software? So CMMI has developed a complete capability maturity model for software and system-oriented processes. But I said, but how do you work with your supplier on software? So I remember a very interesting conversation on the ETCS. And then on the ETCS, they have a baseline every 5 years. Every 5 years, there is a new baseline, not in the wind industry. Every 5 years, a new baseline. What is the justification, the first justification of the new baseline? What is it? The correction of the mistake of the previous baseline. That's the justification, the first one. Thousands of correction of the previous specification. So when you go back to process, I just want to make sure that you get that is all processes that are involved in what you have to do. And it could be also software-related processes or system-related process. And there are some processes with some suppliers that are not at the right level of capability. So the next one is lab testing versus site testing, and in particular, modeling. I insist more and more on this because we can no longer afford testing in situ. It's too expensive, too complex, and we have to go back to modeling and lab testing. And here, I think that there is a dramatic improvement possible because, of course, of the computing power we have and the data science we have, is how we are able to model and simulate and bring this as an evidence to any certifiers or any authority so that we reduce the in situ testing. And of course, when you put that into the relationship with the suppliers, it changes dramatically the way you want to validate the requirement. And the last one is predictive maintenance. So, and in particular, how you deal with your FMEA at system level. So I had one day a very interesting moment in Tokyo. The Japanese culture. Do we have Japanese people in the room? So we have we had a big issue on the metro. The door were slashing. So metro said, we don't understand that. So they park the train, slashing doors. You know, it's not very good. So the door supplier arrives. Oh, it's okay. It's just a bit of not water, but you know, humidity in the door control panel. And the guy said, "What do you mean?" I said, "Yeah, a bit of humidity." So the guys arrive with the hair dryer, starting to dry the door control, and then says, "Fixed." And the Japanese, no. We go back to your maintenance manual. Where is it? Where is the drying procedure? Where is the dryer that we need to use? And it was nothing. So it means that it does not exist. So either you upgrade your product so that there is no need for the dryer, or you ask us to change your maintenance procedure. And the guy said, okay, no problem, we are going to upgrade the maintenance procedure. How long did it take to upgrade the maintenance procedure in Tokyo Metro? 9 months. I can tell you the dryer spec is completely crazy because all the safety issue about who is entitled to dry a door control panel and all the cases and so on and so forth. So, but here again, when you go to what did it fail and to what extent the failure is in line with your FMEA, system FMEA, that's a scary situation. Because if you are back to your system FMEA and you have identified the failure, you're okay. Now, if the failure mode does not exist, then you say, there is something wrong. And here, I think we have a lot to do in this area too. So I will not go back into the recommendation. You can read that after. So I developed for each of them. So I will go fast because of the time. Okay, so the roadmap. So the guys in rail, so I took rail. I did not take aerospace because aerospace is another animal. But I said rail is not very far from what you are doing. Rail guys, they started 20 years ago. IRIS. Who is familiar with IRIS? Yeah. So IRIS is a beautiful initiative. It's about quality, and they have worked 22 years after. They've made a lot of progress so that everybody now is capable to say IRIS is a momentum, and then we bring quality into this industry. Now, in this industry, I consider that you could do something similar, but it's an industry-wide quality initiative where you bring all the parties and you define what you consider is your mandate to bring quality over the life cycle in all dimensions, and you start to sign agreements between all the players, and you start to shift into an industry-wide quality program. So why I'm saying this? Because wind energy has to become more and more predictable versus the economic equation. But it's not only how you are going to deliver the economic equation that you promise, because there is another one to come. So I just want to go there. It's the migration. The system that we are building needs to migrate. Now, the problem we have is that if the system has not followed a very structured quality gate approach, how tomorrow are we going to migrate the system to the next level? And then you could say, but do we have to migrate the system? And I said, yes, there are three main reasons why we have to migrate systems, and they are very challenging. The first one is new regulation. You have new regulation to come that will force you to migrate. The example that I have taken here is cybersecurity. In rail and aerospace, the introduction of cybersecurity in the complete system in the value chain is crazy. It's really crazy. And it's very, very complex matter. I know that it's coming to your infrastructure asset, but that's a new requirement, and it's a new regulation. And you have other regulation to come. The second element is that you may have a new demand. So it means that the utilities or the government may ask you for a new specification or a new requirement, and it's a new demand. So as an example, resilience is a new demand. Before there was no clear specification of resilience, tomorrow there may be one. And the third one is technology. Technology is changing. Over 25 years, you may have to replace one technology by another one. So the critical issue is the migration of the system. Now, are we able to migrate system, yes or no, to make them still competitive? If you go in rail and if you go in aerospace, that's a big moment because the cost of migration is huge. So if you take as an example a locomotive is a simple object, 5 million a locomotive. 5 million. The guys of ETCS, they are coming with a new train control. You have train control into your energy as well. They are asking 500 kilo euro per locomotive to do an upgrade, which means 10% of the initial cost just for an upgrade. Now the owner of the locomotive said we can't afford. So the upgrade becomes a critical element that we need to plan. Now, if we go in any business case, any FID, and we start to go into how much is system upgrade over the lifetime, maybe that the economic equation is no more the right one.
Thank you very much. Thank you very much, Laurent. That was very interesting.
I hope so.
I was very starting to sweat on the different examples there, and then fortunately you said that this doesn't happen in wind. So
no, it's clear. It's clear. Or there is enough wind so that it blows away.
Yeah. No, but I think thank you very much for sharing, and for those of you that didn't notice, you arrived just in time. That's,
yes.
Like the trains, right?
Exactly.
So, exactly. So that was very good. I was just wondering. I have a question for you, because I think the Irish standard. It probably took 18 years or something for that to mature or to get involved, right? In that. So it would be relatively challenging for a industry to adopt in 3 years, right?
Yeah.
So what are kind of the levers or the accelerators that we could apply to get this? I mean, it's not only a part of the supply chain, right?
Yeah.
To work, it needs to be deployed, right?
Yes. So, and here I know that you have a big agenda, and I am a very optimistic guy, but I've become more and more cautious. So I think that when I look to this, I would say that today we are living a moment, an extraordinary moment, because for the first time we have a new enabler, AI, that could help us to bring this back on track and to give to decision maker opportunity to really manage quality in the right sense. An AI enable quality. And I know that you are going to talk about this. And I say, well, I am optimistic because if you bring AI in the equation, you can go very, very fast. Now, the point, and this is why this morning I was provocative, when you go into a transformation where you transform skills, processes, and tools and governance, I think we can do that faster and faster. The issue is the cultural transformation, the mindset of the people. And then here you have a big, big game. Are we ready to change the mindset, our mindset? And this is a big, big conversation because it starts by ourselves. Are we ready to change? Yes or no? When I say that to people, are you ready to change? I can tell you that 95, 96, 97% of the people don't change. So it's not an AI conversation. It's more about we as human beings, are we ready to change and to face the change? And it's not about only a leader somewhere who will have the nice talk. It's about all of us, how we are ready to bring the change and to make it happen. So it's about the cultural transformation.